Today, we're going to do something a little different. We're diving into more than a decade of final science exams. But wait, we're not here to cram for a test. We're here to crack a code, to figure out what these tests really tell us about the fundamental ideas that shape how we see the world. So forget crystal balls, forget cheat sheets. What if you could see what's coming just by understanding the patterns of the past? We're basically going on a detective mission, using years of exam papers as our clues, to find out what truly matters in science. Okay, so here's our mission. We're going to sift through a whole mountain of questions from chemistry, physics, and biology. By spotting the concepts that show up again and again and again, we can actually map out the backbone of a modern science education. First things first, you gotta understand these exams aren't just about memorizing facts. No way. They're designed to test a whole bunch of different skills. You've got your quick 1-mark, do you know this questions, then you've got your 2-mark questions that test a specific skill, and then there are the big ones, the 5-mark questions that really make you analyze and explain things. This structure, it's the key to everything. All right, our first set of clues? They're hidden in chemistry and physics. These questions are all about the fundamental rules that run our universe, from the absolute smallest particles to the biggest cosmic forces. Let's start with a classic one-pointer from the 2024 physics paper. What is presbyopia? It's super straightforward, just a definition. But this shows the baseline, right? You have to know the language of science to even play the game. Now we're leveling up from a simple definition to actually comparing things. The 2024 chemistry exam asks why covalent compounds have lower melting points than ionic ones. See, it's not just about knowing what they are, it's about understanding the deep-down reasons why they're so different. And this is the next level. Right here, you have to take a formula, power equals voltage times current, and apply it to a problem you might actually face. It's a 2-mark question, and it's testing if you can go from an abstract idea to a practical calculation. Can the fuse handle it? You can't just look that up. You have to do the math. Okay, now we're turning to biology. And this is where the patterns get incredibly obvious. I mean, year after year, the exams keep coming back to the same essential ideas about life, the environment, and, well, us. So get this. Here's a question from the 2024 exam. It's a simple request. Draw a neuron and label the axon and dendrite. Seems pretty standard, right? Now let's hop in our time machine and go back to 2020. Look familiar? The wording is a little different, but the core task? It's identical. Draw the neuron, label the important bits. And just to really hammer this point home, here's 2018, the same question again. Now this isn't lazy, it's a massive signal. It's telling us that understanding the structure of a neuron is an absolutely fundamental, non-negotiable piece of the puzzle. And believe me, the neuron is not a one-off. The exams are constantly revisiting the same core topics. Deforestation, evolution, genetics, conservation, they are always on the set list. You could basically call them biology's greatest hits. So what's the crucial thing here? It's that knowing your stuff often means you can explain key differences. In both 2016 and 2018, students could get a whopping 5 marks just for laying out the differences between asexual and sexual reproduction. That tells you just how much value they put on that kind of thinking. And this brings us to the final boss battle of the exam. This 5-mark question from 2024 asks you to connect 2 gigantic ideas: how fossils are made and how they prove evolution. This is more than just facts. You have to tell a story that links a physical process to a huge scientific theory. So, what's this all building up to? Well, across all 3 sciences, it's pretty clear the exams are testing something way deeper than just your memory. It's not about what you know, it's about what you can do with that knowledge. You know that number? 2 marks? It keeps popping up for a reason. It's pretty much the standard price for correctly drawing and labeling a scientific diagram. Doesn't matter if it's a neuron, a heart, or a leaf cell. The ability to visualize science is worth points. This task from the 2024 physics paper is the perfect example. Just like drawing that neuron, it's testing if you can translate an idea, like an invisible magnetic field, into a clear picture. That's a totally different skill from just rattling off a definition. And this really shows you the whole range of skills you need. You have to be an artist for the diagrams, a mathematician for the calculations, kind of like a lawyer for the justifications, and an engineer to apply the rules. This is science in action. So after we've decoded all these exams, what's the big takeaway? Why do these same ideas, these same skills show up year after year, decade after decade? It's because these exams are teaching more than just science.
They're building a whole framework for understanding the world based on 3 pillars: the unbreakable fundamental laws of physics, the interconnected complex systems of biology, and the critical role of human impact on our planet.
Look at this justification question from 2024. It's not asking for a simple pro-con list. It's asking students to weigh evidence, to form an argument, and to defend a position. Questions about deforestation or dams. They aren't just about ecology. They're training future citizens to think critically about the choices we all make.
Ultimately, what a decade of these exams really shows us is that the true goal here isn't just about passing a test. It's about building a foundation of scientific literacy, the ability to analyze evidence, understand complexity, and actually engage with the world's biggest challenges and its greatest wonders.
So we'll leave you with this to chew on. Beyond all the formulas and diagrams, what's the one idea you learned in a science class that has actually stuck with you? The one that still helps you make sense of everything? Because that is the real lesson these exams are trying to teach.